with GeoAI and deep learning workflows. Today's presenters are myself. So my name is Genevieve George. I am a technical solutions specialist here at Esri Canada, and I specialize in data science and GeoAI. I am joined today by Jeff Patillion. Hi, Jeff. Our imagery product specialist, also here at Esri Canada, and we are both out of the technology adoption department. So that's great. Thanks. All right, so we're going to start things off with a quick poll. So yes or no, have you used any of the machine learning or deep learning tools in ArcGIS Pro before? So this could include image classification tools, deep learning tools. It could be with imagery or not with imagery, just through wizards and or geoprocessing tools, maybe through scripting tools. So if you've used ArcPy or the ArcGIS API for Python. So we'll give it a little bit more time, but just yes or no. We want to get a feel for the level of experience of our participants, whether everyone's already used them before or not. All right, awesome. So thank you everyone for answering. So it looks like most of you have used some GeoAI tools in ArcGIS Pro before, but there's very many of you that have not at all, which is no problem at all. We're going to cover most of the basics and then provide some information on the available tools and how to use them regardless of your skill level. So let's look at today's agenda. So we're going to start with an overview of what is GeoAI, just to make sure that everyone is on the same page and understands the difference between AI, machine learning, and deep learning, and what they mean in a geospatial context. Then we're going to look at the applications of AI in GIS and imagery, specifically how computer vision can be used to tackle geospatial problems. And then we're going to transition into a series of demos. So it'll be a demo-heavy webinar. We'll start with a basic image classification using some machine learning tools that have been around for a long time. After that, we'll transition into some of the newer tools. So we're going to look at the deep learning tools. We'll look at a full workflow from start to finish, start being collecting data all the way to running the tool or running the model on data it's never seen before. And then we're going to transition and follow things up with a look at the pre-trained deep learning models. So those allow you to skip all the complicated resource intensive steps and get straight to the results for some common imagery tasks. Okay, so before we talk about GeoAI, we need to talk about AI or artificial intelligence. So AI is a term that's used to describe machines that mimic intelligent human behavior. So it's a very broad category that encompasses everything from ChatGPT, which is probably at the forefront of most people's mind, to translation software, to your computer partner if you play chess, to image classification, even to all the way to hypothetical robots that can take over the world. So it's a very, very broad category. And all of those examples are of machines that can mimic in some way or another the problem solving or decision making skills of humans. Now, within the umbrella of AI, we have machine learning. Machine learning is a subset of AI where computers use algorithms and models to learn from and make predictions on data. So machine learning leverages data to teach a computer to draw inferences without being explicitly programmed to do so. Generally, machine learning follows a workflow of prepare training data, train a model, and then use a model. So once the model is defined, you can give it data that it has never seen before, so other than the training data that it learned from, and it runs through the model algorithm, the series of rules and decisions that the computer has defined to be able to distinguish between various input data, and then gives an output or prediction. Now, deep learning is a subset of machine learning. So it's we're working downward, we're nesting our ideas here. And deep learning uses artificial neural networks to mimic the learning process of the human brain. So deep learning follows that same general workflow of collect training data, train a model, and then use a model, but it differs in terms of the model itself and what that model is doing and the types of algorithms that are being used. So in deep learning, the model is built with artificial neural networks to mimic the learning process of the human brain. Whereas classical machine learning uses other kinds of algorithms, and that could be things like regressions or decision trees like random forest. So it's still performing a similar task, but the models and the algorithms that are working are very, very different. So these deep neural networks have the ability to extract features. So what does that mean? So let's say I wanted to differentiate between apples and oranges. Um, if I was using classical machine learning, I need to provide what those features are. So I need to say that an orange is orange colored, that it's the size of a softball, that it has rough texture versus an apple, which is smooth and red, etc. Whereas deep learning can extract those features itself. Now, in practice as end users, and particularly imagery end users, this doesn't change on our end very much when we're trying to do a task. Because with imagery, we're generally providing it with the bands of an image anyway. So the feature extraction is, it can do more than we can, but we're still are providing it with the bands. But it does mean that deep learning has more applications than classical machine learning and that it benefits from having more data. So the more training data, the better the model will perform on new data. Generally, classical machine learning will plateau at a certain point. So the more data you give it past a certain point, it's not necessarily going to improve, whereas deep learning thrives on having that extra more and more and more data. So it's especially useful in the age of big data. So what is GeoAI? Well, GeoAI is a bit of a buzzword and it's not really a new thing, but it's become more to the forefront just as AI has risen in people's understanding of what it is. So it's really just the intersection of AI and geography. So it's the use of AI methodologies like machine learning and deep learning to solve geospatial problems. Now, in GIS, machine learning and deep learning are tools, just like other tools that exist, like geoprocessing tools. It's simply a workflow that we can then apply to either automate tasks or get outputs. So again, it's not a new field, but it is one that is becoming particularly, that it's growing because there's more and more opportunities to apply artificial intelligence methodologies to geospatial problems. So we've spent a bit of time discussing what GeoAI and deep learning are, but let's talk about what the actual uses of them are in in GIS. One of the best applications of deep learning in GIS is in computer vision, which is essentially the ability of the computer to see. So if you look at these images I have here, on the left I have this zoomed in high resolution image, then I have in the middle a traffic camera, and on the right there's a satellite image of a city. So naturally, our brains and our eyes, our optical structure in our brains are able to detect patterns and detect objects within these images, right? If I'm looking at the left image, I can see cars and roads and trees. I can see a parking lot. If I'm looking at the middle one, I can see that there's cars and traffic lights and pylons. And then on the right, I can see the pattern of the different agricultural fields that are surrounding a city. So I know what those objects are, even if I don't know specifically it's a cornfield versus a soy field, I can detect that those are agricultural fields. Now, computers traditionally can't see those things, right? They're just interpreting the image as a series of pixels. However, it can be taught to see those same things that we are seeing. So machine learning can be used for things like land cover classification and object detection and object classification, where you teach the computer to determine which pixels belong to which land use type. So which pixels make up, a pavement land use type, and which pixels form a car object or a parking lot object. So those are things that the computer can be trained to do, particularly if they are easy for us to detect. So if it's something we can easily see, it's a good bet that the computer can be trained to see it as well. So the main subsets of computer vision are here, or computer vision for GIS specifically are here. So starting with image classification, this is really just the labeling of an image as a whole. So in GIS, you can think of this as a geotagged photo. So on the left, we have dense crowd. On the right, we have cat. So it's really a label for the image as a whole. It's not looking at anything within the image specifically. Then we have object detection, and that's where we're looking at specific objects within an image. So we can see that there's this airplane object here, which has a box around it. And then on the right, we have these animals. So we have dog 1, dog 2, and cat. So it's looking for objects within an image. And this is able to do it with many, many objects in an image. Say if you were looking for, cars in a satellite image. Then there's semantic segmentation. So this is not always referred to as semantic segmentation colloquially. Often this is just called pixel classification or even image classification, but careful not to confuse it with the one above. So semantic segmentation is where we are assigning a class to every single pixel in an image. So on the left there, we have a satellite image. So I believe we have the yellow is a road class, and then purple could be non-road class or non-impervious surfaces, etc. Then the cat is showing all of the pixels in an image belong to a certain class. So we're not just looking at the cat object itself, we're looking at everything around it, the sky and the grass and whatever the purple is. Then we have instance segmentation. And instance segmentation is kind of a combination of semantic segmentation and object detection, where you're looking at specific objects, but you're also looking at all of the pixels that make up that object. So for these houses and for those cars, we're not just drawing a box around it and saying, here's an object. We're actually saying, here are all the pixels that are defined, that define this object. So those are the main ones that are useful in GIS. So with that, I'm going to hand it over to Jeff to discuss semantic segmentation, or known more commonly as pixel classification.
All right, thanks, Jen. Hi, everyone. So I wanted to first start off with a little bit of Esri history and how that relates to GeoAI. So the history of Esri products goes back to the 80s with the release of the first modern GIS in 1982. From looking at this graphic, you can see the evolution of products since then. But where does GeoAI fit into this picture? Many of you may assume it's a relatively new technology, but that isn't quite the case. Nowadays, when you think of GeoAI and ArcGIS, you may be thinking of the deep learning toolset. So this was introduced to ArcGIS Pro in version 2.3 in 2019. However, the concept of machine learning has been around in Esri software for a lot longer than that. In fact, machine learning capabilities have been a part of Esri software for over 20 years now. Specifically, the spatial analyst extension introduced in the early 2000s with ArcMap combine machine learning with certain geoprocessing tools to complete raster-based analysis. You may have even used some of these tools in the past and not even realize that you're doing GeoAI. So these tools have improved over time and they still exist today. So you may be wondering, what are examples of these tools? So the answer is image classification tools, or as Jen described earlier, semantic segmentation tools. So image classification at its core is a great example of machine learning. In ArcGIS, image classification is used to assign classes, known as a schema, to all pixels in a raster to create a thematic-based raster. And that is a raster that now has attributes associated to it. So image classification can be used to calculate any visible feature within a raster, and is often used to look at change detection, damage assessments, and the big one, which you may have used in the past, is to calculate land use and land cover. So image classification methods follow an iterative process. Users configure, they train, they classify, you can merge, you can reclassify. And just by looking at this diagram here, you can see how this is an example of machine learning. So these steps can be completed individually in ArcGIS Pro or through a streamlined workflow using the image classification wizard, which helps guide users through a step-by-step process. So let's take a look now at the image classification wizard in ArcGIS Pro to see image classification in action. So here in ArcGIS Pro, I have my high resolution imagery, and I'm tasked with calculating the impervious surface areas for this study area. And that's going to be areas that can't naturally soak up water, such as pavement or rooftops. So to start, we're going to click on our imagery tab at the top here. And then we want to make sure that we have our imagery highlighted in our table of contents. Now we can click on our classification wizard, and the image classification wizard is going to open up on the right-hand side here. So our first step is to configure our parameters. So we'll start with our classification method. We have two options, supervised or unsupervised. Supervised, like the name suggests, involves the user determining the classes, whereas unsupervised lets the computer decide. Today, we're going to look at supervised. Our next choice is the classification type. Again, we have two options here, pixel-based or object-based. Pixel-based is the traditional method that looks at each individual pixel within a raster and doesn't consider any neighboring pixels, whereas object-based takes in considering these neighboring pixels and helps group pixels together into objects or segments. The classes are then assigned to these segments, whereas with pixel-based, the classes are assigned on a pixel by pixel basis. Today, we'll look at object-based. Next, we can choose our classification schema. So we can see here we have a few options, including generate from training samples. So with supervised, another aspect involved is in creating training samples and having some knowledge of the area, including vegetation and terrain. So I went ahead earlier and digitized our training samples for this area. So you can see here in our table of contents, we have our training samples. You can see we have field, road, trees, etc. So I'm going to use these training samples I created for our schema today. So I'll go ahead and browse to where these are located and go ahead and hit OK. Also in this optional option here, I'm going to specify that my training samples already created. This will help speed things up through the process. If I didn't choose this option, I'd still have my schema in place with our different class names, but I'd have to go through and redigitize my training samples. So I can specify here that our output layer is going to be a raster, and I can choose an output location if desired. I'm going to stick to this default for now and hit next. So the first step in object-based classification is to do the segmentation process. So generally with segmentation, you're going to want to have a high spectral detail and a low spatial detail. These values are something you might have to experiment with to find the optimal results. But today I'm going to use 17 for my spectral, 3 for my spatial, and then for this option at the bottom, the minimum size in pixels, that's just going to specify the smallest pixel group we're going to have. So I'm going to bring this up to 50. Then I'm going to hit preview to see our results. So take just a few seconds here. And you can see now it's grouped similar pixels together into our objects. It's grouped this row together, it's grouped this building together, and you can see how the field's been grouped together. It almost looks like a cartoon-like image. So I'm happy with my results now. I'm going to go ahead and hit next. So the next step is the training samples manager. But like I said earlier, I've already gone ahead and created our training samples. So we can skip this step. We do have the option if we wanted to add in more samples, but we can forget about that for now. Before I hit the next, we can just see the number of samples I've created earlier and the pixel percentage is taking up. So now I'm on the train stage. Here I'm going to choose what machine learning algorithm I'm going to run against my imagery to assign the classes. We have a few choices to choose from, but today I'm going to look at the support vector machine, which optimally separates the data into different classes. Again, this is something you might have to experiment as each classifier varies a bit different, but today let's just choose this support vector machine. I'll stick with the default number of samples per classes at 500. And for my segment attributes, I'm going to choose every option except rectangularity. I find that rectangularity works best with images with very sharp edges, but you can see from our image here, we have lots of curves and kind of natural rounded edges. So I'll forget about that for now. I can go ahead and hit run, and this will come up with a preview of our classified raster. This is going to take a bit of time, so I'll just skip to the results here. So now you can see we have a preview of our classified raster. And how that works within the image classification wizard is that it's based on your screen resolution. So if I adjust my scale at the bottom here, it's going to change our results. So you want to find what screen resolution works best to show you results. So I'll try 1 to 1000 here. And I can see that shows my results really well. I can query a spot. You see this is road. This is roof, field, etc. I'm happy with my results like this, so I can go ahead and hit next. And this is going to export our classified raster. So I can go ahead and give our classified raster a name. Now I have some options for some additional outputs that would help with rerunning a classification in the future, but I'll skip these for now. So this will export our classified raster. And once it's exported, our values will be locked into place. So when I change my screen resolution and zoom in and zoom out, it's not going to change our values. So there you can go. You can see our classified raster here. So I can hit next. So now I have the option to merge classes if desired. This is our classified raster we have here. We can skip merging classes. So that's a good step if you want to merge similar outputs. For example, if you had multiple different tree species and you wanted to merge it together as one tree class, but we can skip that for now. So I do have a reclassifier option now. So now that I've classified my raster, I have noticed an area that was classified incorrectly. You can see this area is classified as a road, but I know that it should be classified as a field. So I can choose this reclassify within a region option and choose my current class to be a road and my new class to be a field. So I can just digitize on my image here. We have a preview of our results, and I'm happy with that. So I can give our reclassified raster a name. Go ahead and hit run. And now I have my final reclassified raster. So I can go ahead and hit finish in my image classification wizard. And this is where I could go through and now do calculations and analysis to get exact measurements of my impervious surface areas. But this is where I'll stop and hand things back to Jen.
All right, awesome. So we just saw an example of some GeoAI functionality in ArcGIS Pro that has been around for a while. And now we are going to transition to some functionality that is newer with a look at the deep learning specific tools in ArcGIS Pro. So first, to work with deep learning in ArcGIS Pro, there are a couple of prerequisites. The first is license extensions, and this will depend on which specific deep learning tools and toolboxes you are using. So for most of or everything that we're seeing today, this is available with the image analyst license, but not all deep learning tools fall into the same toolbox. So for things like if you're working with point clouds, for example, then you would need the 3D analyst toolbox. So just to make sure whichever one whichever kind of tool that you're using, you'll have to just verify that you have the right extension. Then there's also the ArcGIS deep learning frameworks. So these are just Python packages or Python libraries that you need to install into your ArcGIS Pro Python environment. Luckily, this is super, super easy and it's free to do. So I've added resources at the end that show you how to do this, including a quick video. But basically, these are what's working in the back end when you're using these tools. So having a license extension isn't enough. You do have to install the deep learning frameworks in order to avoid the dreaded error 9999999. The last thing is not mandatory, but it is highly recommended that you have a CUDA compatible GPU. So the reason is the deep learning models are a very resource intensive task. So the higher your processing power, the better the model performance is going to be, the easier it will be on your computer. So again, it's not mandatory, but it is highly recommended. You'll see much better performance. So once you're set up with your hardware and your software, you are ready to start with the deep learning in ArcGIS Pro. So the overall steps are here, and this is, again, the same as we mentioned earlier. The first thing is prepare training data, then train a model, and then use a model. But let's look a bit more specifically at how that works in ArcGIS Pro. So I'm going to break that first step of prepare training data into two sub-steps. The first, collect your training data, and the second is format training data. So for step one, you need to have the training data collected, right? So this will depend a little bit on your task of what exactly you're trying to do. So we saw in Jeff's demo that was just little polygons of the different land use areas. Object detection would be a little bit different. You'd want polygons of the specific objects. But pretty much either way, you're going to have a feature class with classes, probably a polygon feature class. And there are tools to help you create this training data, or you can use a feature class that already exists. Then the next step, once you have that feature class, is to format the training data. So the input for training a deep learning model is not a feature class, it's actually image chips. So you need to use the export training data for deep learning tool to convert your feature class into folders of labeled image chips. And the exact way that those image chips are formatted and the metadata that's associated with it will vary based on the type of model you're using. So that needs to be considered at this step. Once your data is formatted, you need to train the deep learning model using the Train Deep Learning Model tool. So here is where you'll specify which model you're going to use, which again will vary depending on your task. There are multiple options for the different types of tasks, and I've listed just a couple of them here. But again, this ties back into the metadata. So if you are using mask RCNN, you're going to have a specific type of metadata versus some other models will require a generic type of metadata or a specific type of metadata. So again, I've listed a couple of them here, but there are many more to choose from that will vary depending on what exactly you're looking to get out of your model. Then once the model is trained and has good performance, you can use the model to inference. So here you will pick your geoprocessing tool based on what kind of model you created. For example, for a land use classification model, you would use the classify pixels using deep learning tool. And for object detection, you would use the detect objects using deep learning tool. All right, now let's get out of slides and show what this workflow looks like in the ArcGIS Pro environment. So to start, I have ArcGIS Pro open here, and I have a high resolution image of Miami. So I'm going to zoom in. We can see, once I zoom in, that there are many anchored boats in the water. So that's what we're going to be detecting for this demo are these boats. Not the ones at the dock or moving around, but specifically those that are floating or at anchor. Now, if you'll recall, the first step that I need to do to build a deep learning model is to collect the training data. So I'm going to use one of the wizards that's available to help me collect my data in the right format for the tools that I will be using. So I have my image selected in the table of contents, then I'm going to the imagery bar and selecting classification tools. There's a couple of different wizards here, and for this task, I'm going to select label objects for deep learning, which opens this new window. Now at the top here, I have the schema window, and I can either choose an existing schema. For example, if I already had a schema with land cover classes or boat types, but I can also just create a new schema by clicking the green plus and entering the name and value of the classes. So in this exercise, I'm only interested in detecting one type of object. I'm looking at boats, but I could add other classes here if I was looking to detect other kinds of objects. So floating boats versus boats at dock, for example. Then at the bottom here, I have my labeled objects. I haven't created any, so it's currently empty, but I can load an existing table of training samples to add onto, which is what I'm going to do. So I'm using that existing feature class. So I'm just going to select it here. And now I want to add additional features. So I can use these tools at the top. I'm going to zoom in and select the rectangle tool. And that's how I'm going to add extra objects. So it's super easy. It's just, for this one, I'm using the rectangle because I'm just going to draw a box around my different objects. So click, click, and drag, and then click, click, and drag. So if I had a circle, I would want to use maybe the circle like for a tree, but this works well for me. And then I can see as I scroll down here on the right, those last three yellow ones are the ones that I've just added. So now I'm going to save this. I'm going to go to the top and save it as this updated file. Now, the next step is to format the training data for deep learning. And we can do this in this wizard by going to the Export Training Data tab. Or we can also use the Export Training Data for Deep Learning Geoprocessing tool that's located in the Image Analyst toolbox. They do work in the same way though, so I'm just going to continue using the wizard because my objects are already loaded. So then I just have my output folder, which will be a folder with image chips, labels, and metadata. And then again, I need to decide on my metadata format. I'm going to choose RCNN masks because I'm going to be using the mask RCNN model later on. Then I'll just leave the rest of the parameters as default and hit run. So again, RCNN is a specific one. There are some metadata formats that are a little bit more generalized. So once the tool has run, I'm going to end up with this folder that has image chips. So I'll just open it up. So it has image chips and the different metadata that I need to use to train the deep learning model. So back in ArcGIS Pro, I'm going to close the label objects pane and then go to the geoprocessing pane and find the train deep learning model tool in the image analyst toolbox. Here I need to set the input training data as the folder I just created. So the entire folder that had the image chips and the metadata and all that. So I'm just choosing the folder's name. Then I'm going to wait for that to load for a sec. And then in the output model, I'm going to choose an empty folder. So it's giving me a little exclamation point here, but that's just because that folder already exists, but it's empty, so it'll work perfectly. Then once the input training data is loaded, the model parameters will also become available to populate, and you can tweak them as needed. I'm going to leave them as default, but I'm going to talk about them. So the max epochs here is how many times the model will see the training data. Lower values will take less time to train, and higher values will mean more training time. Then the batch size here will depend on your computer's memory. So the more memory you have, the higher this value can be. If you get any errors or any memory errors specifically, this value will probably have to be lowered. Then below that, we have these model arguments, and those are going to be specific to the model type that you chose. So in this case, because I chose the model RC or the mask RCNN model, I have chip size and monitor. And chip size is the size of the clipped image chips that will be the input. Default is good, but if I wanted to provide more context of what surrounded an object, I could do that. And then monitor is validation loss, and we'll talk about that. It's a measure of the performance of the model. In the advanced section, we have further parameters that can be tweaked, but I'm going to leave everything as default and hit run. Now, in the interest of time, because this takes about 2 hours, I have already run this tool. So let's just take a look at what the output from that was. So I'm going to go to the folder that was the output. And in there, I have the model files, including the DLPK file, which is the deep learning package, as well as the model metrics and model characteristics. So let's open the model metrics to see how the model performed on the data. Here we are given the training and validation loss curves, the precision score, and the comparison of some sample results. So starting with the training and validation loss curves, the lower the loss, the better the model is working. So this is an over time over the number of batches. So this tells me that my model is probably overfitting to my data, to my training data, because the validation loss is higher than the training loss. It isn't too bad. Ideally, we would see these two lines converge, which would mean that our model is working equally well on the validation data as it did on the training data. But it's not too bad. Then we have a precision score is 81%, which is pretty decent. And the sample results are also pretty decent. So they don't show any major issues. Overall, the model works fine, particularly since we just use all the default parameters. It could certainly be improved, but in the interest of time, let's just use the model to detect boats in an image from a different year and see how it performs. So back in ArcGIS Pro, since we created an object detection model, we are going to use the detect objects using deep learning tool in the image analyst toolbox. Now our input raster will be Miami 2019. So it's an image for the same area, but for a time period that's 3 years prior to the image used to train. Then I'm just going to change what my output detected objects name is going to be. I'm going to say detect boats. That's the feature class. And then for the model definition, I'm going to find the DLPK file from that folder we just looked at. Then we'll leave the rest as default and just hit run. Again, in the interest of time, I have already run the tool. Again, it was about 2 hours for this one as well. So let's inspect what our results looked like. So this is the anchored boats feature class that I end up with. So we can see that it works kind of well. It works pretty well in some areas and then a little bit less well in others. It seems to miss some boats, but it doesn't select anything that isn't a boat, which is pretty good. So again, if we were to tweak the parameters, we could probably see much better results. But given that we left everything as the default, I would say it worked pretty well. Can't complain too much about that result. All right. Now I'm going to go back to the slides. So just as a follow-up to that, that demo, I just want to talk about how we could improve the model performance. What are the kinds of things that we could be tweaking here? So I've split it up into kind of 2 categories. We have the model parameters and the training data. So model parameters, some of them are general, right? No matter which model you use, you can adjust the learning rate of how the deep learning model is learning. The default is pretty good because it's an algorithm that's running in the background to find an optimized rate, but you could adjust it if necessary. The other thing would be adjusting the number of epochs. So, increasing the amount of time that it has to train could be helpful. Then the other thing you can do is adjust the training data itself. So for this, I could add more training data. I had only 400 boat samples that were included when I was training it. So again, deep learning, the more data, the better. If I had gone up to 4,000 boat samples, I would probably see much better results because I'm giving the model more to understand. And especially since I saw that it was missing some boats, it's probably because I didn't have enough training data for it to be able to identify those as boats. Another thing is adjusting the chip size. So for the boats specifically in this case, they are small objects and the image chips were surrounding quite a bit of water around them. If I was looking maybe at docked boats or a farm, for example, I might want to give more context. So a larger image chip would accommodate providing more context for the model. The last here is data augmentation. So this is a way to, if you are limited in how much training data you have, so let's say you can't just select more boats, you can use data augmentation to artificially increase the number of samples or the amount of training data that the model is learning from. So this is literally taking those image chips and like warping them and transforming them so that they look different enough that you can basically train the model to see that boat from another angle, essentially. Not exactly, but that's the idea. So you're artificially augmenting the amount of training data you have. All right. So that's it for the full workflow. So we saw the full workflow from collecting training data to looking at the model and then using the model. And now I'm going to hand it back over to Jeff to look at the pre-trained deep learning models.
All right, thanks, Jen. So training a deep learning model can be a time-consuming process that requires a lot of computing resources. That's why Esri has introduced pre-trained deep learning models. So these are going to be models where the first two stages of the deep learning workflow have already been completed for you, allowing you just to run the model and review the results. This eliminates a variety of requirements and ultimately frees up lots of time and resources for the end user. So these are going to be specific models that are tailored to the deep learning task and data type they are trained on, but they're going to be available for common deep learning workflows. So these pre-trained models can be downloaded from the ArcGIS Living Atlas, and you can use them in ArcGIS Pro, ArcGIS Online, and even ArcGIS Enterprise. There's approximately 60 models available, including the new Segment Anything model from Meta AI. And like the name suggests, it lets you extract almost any object from your input imagery. If you're interested in the Segment Anything model, we have resources at the end of these slides and in the story map, including a video and a how-to guide how to use this model. So the inputs for these pre-trained models can be anything from imagery, 3D point clouds, video. There's a whole bunch of models available. So let's take a look at the Living Atlas now to see some of these pre-trained models. So all you have to do is go into your internet browser and type in ArcGIS Living Atlas. We can hit this first result at the top, ArcGIS Living Atlas of the world. And then in the search bar here, we can simply search deep learning. We will then hit this Esri only content to see all the pre-trained models created by Esri. You can see we have about 60 results. Just viewing these here, we can see there's a variety of different models for a variety of different workflows. So let's hit this first one at the top here. And it'll open up in a new page. On this page, we get a description of the model, including licensing requirements and a link to a guide. So if you click on this guide here, again, it will open up in a new window and it'll give you a how-to guide, including step-by-step instructions on how to run these pre-trained models. So I highly recommend checking out these guides if you're interested in these models. Also on the description page, we have information about applicable geographies, output, and input. Always take into account the geographies and input when running these pre-trained models, as they were trained to specific data. The input's going to be especially important when you're running a land cover classification for Sentinel-2 or Landsat 8. If you use incorrect data, you will get an error. So once you have found a model you're interested in, all you have to do is hit this download button. and it's going to download the deep learning package to your computer, also known as the DLPK file. Alternatively, you can actually access these deep learning models within ArcGIS Pro. So within ArcGIS Pro, you can hit the catalog, portal, living atlas, and again, search deep learning. And we have access to the DLPK files right from ArcGIS Pro. We can simply drag and drop these into the geoprocessing window when ready. So today we're going to look at the car detection model. And what this model does is it detects cars in high resolution imagery that you collect from a drone or from any aerial source. So the car detection model is great for urban planners and can be used for traffic management and parking lot utilization. So for this model, sorry, I can't see. I want to detect objects. So I can simply type in detect objects into my ArcGIS Pro search bar and click on the result here. This will open up the geoprocessing window for detecting objects using deep learning. My input raster is going to be my high resolution imagery. I can specify an output location. So our results can either be a shapefile or feature class, depending on how you want to save your data. And then for our model definition, this is when we'll bring in the DLPK. So I'll browse on my computer for where I have it downloaded and click OK. It'll take a few seconds here for the geoprocessing window to get set up. And I'll have some options to change some parameters if desired. For this model, I'm going to keep things as the default. And when I'm ready, I can hit run. So now you can see we have these options available, but I can go ahead and hit run. But to save some time, as the time this will take depends on your computer and your imagery. So just to save some time, I will show us our results here. And you can see the model has gone through and has identified all the cars within our imagery. So let's take a closer look here. And you can see it's done a good job at identifying all these cars in this parking lot and on the road here, but it hasn't identified some of these larger vehicles, such as the semi-truck here, these dump trucks, and these bigger vehicles here. Again, this is just a reminder that these models are trained on specific parameters. So let's take a look at another example now. So here I have some Landsat imagery that I've exported from the Living Atlas, and I want to run a land cover classification on it. So what I can do for this is I'll search up classify pixels using deep learning. So my input raster is going to be our Landsat imagery. We'll specify an output location. For our model definition, let's drag and drop it in from the catalog this time. So I'll go to my portal, Living Atlas. Again, I'll search deep learning. And now I have my land cover classification for Landsat 8. So let's bring this in. Again, this will take a few seconds just to get things set up. And once I'm ready, I can hit run. I do have the ability to change any of these parameters if desired, but I'll keep them as default for today. So a few more seconds here and it should be good to go. So I can go ahead and hit run. And you can see not long after I had a deep learning failed. So I did this on purpose. I wanted to show you guys what would happen if you use an incorrect input when trying to run one of these pre-trained models. So let's take a look at our imagery and see why this happened. So I'll go to my properties of my raster. I'll click on source. I look at my raster information and I can see that there's 3 bands here, but I know that Landsat imagery should have 11 bands. Because this is not lining up, this is why I have the error. So let's take a look at the correct imagery here and see the difference. Now I can see that this is the correct 11 band imagery. So if you're interested in learning about downloading data from the Living Atlas for Landsat, you can check out Jen's GeoSnap video available on the Esri Canada YouTube page, and it's also linked at the end of this presentation and in the story map. So now if I grab the correct Landsat imagery and I hit run, we can see that it's working and I get the following results here. A perfect land cover classification for this area. Again, I just wanted to reiterate how important it is to always look at your inputs and your geographies, follow the how-to guides when running these pre-trained models, as it'll make your GeoAI workflows much easier in the future. So that's it for me, and I'll hand things back to Jen.
Awesome, thank you. So I'll steal the screen back. There we go. All right. So that mostly concludes the content we have for our presentation. I just want to go over quickly a summary of what we've looked at today. So we started with what is GeoAI. So we looked at what artificial intelligence is, how it relates to machine learning and deep learning, that those are methodologies that belong under the category of the overall arching category of AI. And GeoAI is specifically the intersection of geospatial technology, geospatial problems, geospatial problem solving, and AI methodologies. Then we looked at applications of GeoAI with imagery. So we looked at computer vision. We talked about semantic segmentation, which we also call pixel classification or image classification. So stuff like land cover classification. We talked about object detection, and those are really like the best applications, in my opinion, the best applications of GeoAI with imagery. Then we went into a series of demonstrations. So we looked at the machine learning with the image classification wizard. Then we went into more of the newer tools with the deep learning workflow. So we saw from start to finish, from collecting your data to training the model to inspecting the model performance, and then ultimately using the model. We saw the whole deep learning workflow there. And then we followed up with the pre-trained deep learning models. So skipping all the hard work, not having to train your model yourself and deal with all of the complications that inevitably arise with that, just using the ArcGIS pre-trained deep learning models to quickly get a wonderful result. Honestly, a lot of them work really, really well. And I highly encourage you to check them out on the ArcGIS Living Atlas to check out the ones that might be suitable for your work. All right, so here are the training resources. So these will be available. We are sending a follow-up email, so don't worry about writing down all of these long URLs. They will be provided to you. We have some additional resources here. I mentioned the installed deep learning frameworks for ArcGIS. So I have a quick video there, and then also the instructions on how to get that done on your computer. Again, it is free to do. So if you have access to the tools, but you're getting an error when you run them, that's probably because of you're missing the deep learning frameworks. Then we also have, the Living Atlas there and some specific examples of, or some specific videos to show you how to download imagery and use some of the pre-trained models in ArcGIS Pro. So with that, I want to thank everyone so much. So the recording will be sent to your email and available online at that link. If you have any additional questions about the content, feel free to contact us. So we will spend the next 9 or so minutes looking at the questions that you guys have asked. There are quite a few, so we'll sort through them and do our best to answer as many as we can. We will do a follow-up blog with a Q&A. So we'll look at the questions that were asked and produce a blog that answers those in sequence. So if we don't get them today, or we don't get to them today, keep an eye out for that. And then again, our information is here if you want to reach out to us directly.